What's up guys, it's Pedro here from newcoder.com, and in this tutorial we're going to be talking about removing the last node within our linked list. So to get started, you can see that we have a linked list. It has 4 nodes within it. Header is pointing to the first node and tail is pointing to the last node. Now there are actually 3 cases to consider. One is, what if the list is empty, and in that case we're not going to do anything. The second case is, what if the list only has 1 node. And the third case is, what happens if it has more than 1 node. The second case is pretty simplistic. First, we would need to test to see whether or not there's 1 node within our linked list. And there's 2 ways to do that. One is to check if the size is equal to 1, and 2 is to check to see if the node that header is pointing to points to another node. If the node that header is pointing to points to null, for example, that means there's only 1 node within our linked list. And then from there, we would call the remove first method that we coded in a previous tutorial. So if you want to take a look at how that's done, you could check out that video. So now let's move on to case 3. What happens if there are multiple nodes within our linked list? So you might be wondering to yourself, I have a tail pointer and tail is always pointing to the last node. Can't I just delete this node and then that's it? I already removed the node. So let's take a look at that example. Now, what would be the problem of doing this? Well, I successfully deleted the node just like the remove last method is supposed to. But now tail isn't pointing to anything. Tail is always supposed to point to the last node. So you might be saying to yourself, well, I saw your remove first video. Can't I just have the pointer that points to the previous node? And the answer to that is no, because we have our nodes designed to only point one way. So I could go this way, but I can't go backwards. So the only way to do this is to do what we did with our print method, and we're going to have to traverse the list. So let's take a look at that example. So now by traversing the list, we're going to need 2 additional pointers. One pointer is going to point to the current node, and the second pointer is going to point to the previous node. So now this is how we're going to initialize it. Current is going to point to header. That's going to be our starting point. And prev isn't going to point to anything. So now let's pretend that we're inside a loop. Execute this loop now. So the loop executes. The first thing we're going to do, prev is going to be pointing to what current is pointing to. Then current is going to advance to the next node. Execute the loop again. Prev is going to be pointing to what current is. Advance what current is pointing to. Execute again. Prev is going to be pointing to what current is. And current is going to be pointing to the next node. Now this is when the loop stops because now we hit null. So now let's think of this logically. What should we do at this point? Well, the first thing we should do is update what tail is going to point to. Well, the first thing that we should do is have tail point to the new last node once we remove this node. And who has a pointer to the new last node? Prev does. So let's update that. Next, what we're going to do is set this node to point to null. And last but not least, the last step is to delete the node that current is pointing to. And from here, we just decrement the size. Alright, so let's actually take a look at this in C++ code. Alright, so from here, you can see we have our remove last method. It's not returning anything, and we're not passing it any parameters. So case 1, we don't have to directly have a conditional statement test for this. So we're just going to leave that empty. Case 2, let's test to see whether or not our linked list only has 1 node. So I'm just going to say if header arrow next is equal to null, then we're just going to recall our remove first method. Alright, so let's move on to case 3. What happens if the list has more than 1 node? So I'm just going to say else if header does not equal to null. What we're going to do is create our 2 pointers. Current is going to be initialized to whatever header is pointing to. Next, we're just going to declare our previous pointer. So now let's actually write the loop. So we're going to keep going until we hit the last node. So all we need to do is just say while current arrow next does not equal to null. We're going to keep advancing. So the first step, prev is going to point to whatever current is pointing to. Then we need to advance current. So current is going to be pointing to current arrow next. And last but not least, let's actually start removing the last node. So now I'm just going to say tail is going to be updated to point to prev. Remember, prev is pointing to the new last node. Next, we're going to set this node to remove its pointer from the last node that we're going to delete. And the last step is to delete what current is pointing to. Decrement the size. So now let's actually test this out. So I'm just going to go down to our main method. And let's get rid of some of this. So now I'm just going to say list.remove last. And our last node should be 3 right here. So now I'm just going to print out the list. I'm going to save this. I'm going to go to my desktop. Let's compile this. Let's execute it. And you can see 10, 1, 2, 3, 10, 1, 2, and 3 is removed. Let's test to see if this works with one node. So I'm just gonna append one thing and we're gonna print that out, but let's remove it. So now let's save, let's recompile and execute the code one more time. And you can see that our list is empty. So that's pretty much how you could code our remove last method for our linked list.